Okay, we don't want to beat a dead horse, but we just want to just make sure that we understand everything that's going on here in this TS diagram because it's very useful. The next thing we talk about is the wet vapor region, and we've talked about it before, but anything under this curve is called a wet vapor because it's a mixture. It's a mixture between a water and a vapor. We know that this is right here 100% water, so it is 100% moisture content. But here, there's no water, there's all steam, and it has 100% quality. In between those two, at that pressure, is a mixture, and we call that mixture a wet vapor. That's a K&A requirement. We refer to this area underneath the critical point as the vapor dome. The vapor dome, and we know it's a wet vapor dome. If I'm on the line, on this side, I'm a saturated vapor. If I'm on the line, I'm a saturated liquid. Also, you need to be able to identify those. The vapor dome, the saturated liquid line, the saturated vapor line. What's really cool is we've included a heat addition summary right here with a very simplified version of what's going on as you add energy to 1 pound mass of water. So you come down here, and I have 1 pound mass of water in a pan, which corresponds to this 0.1 down here, and it's subcooled. I just took it out of the faucet, and I start to add energy to it. While it's still subcooled, there's the equation that we have that I could find the enthalpy of a subcooled liquid down there before I reach the saturated liquid point. And remember, it was equal to something less than H sub F. And we say it's T sat minus T actual multiplied by C sub P, the specific heat capacity. Once I reached saturation, so I'm a saturated liquid, I have 1 pound mass of saturated liquid in that pan. Look, the quality is 0, the moisture content's 100%, and it says H sub F. I'm at the enthalpy of a saturated fluid or liquid. And as I start to add energy across it, once I get halfway across the vaporization line, I've got 50% water, 50% moisture. I'm sorry, 50% steam and 50% moisture. Therefore, if I was to solve it, the quality is 50%, and I could use that and determine the enthalpy at that point. This is super important. The enthalpy at any point along the vaporization line, enthalpy at X, anywhere along the line, so from turning from a saturated liquid all the way to a saturated vapor, I know I can look up the F point in the steam tables, and I can look up the G point, but I have to solve in between there. And the way I do that is wherever I am, anywhere along that line is going to be at least equal to H sub F. It's going to be something greater, so it's going to be plus the quality times H sub Fg. Now what's important to note, remove this, I can use this equation, this form, for any of the properties that I'm trying to find out along the vaporization line. In between these 2 points, the F point and the G point, if I want to find out a property anywhere along that line, let's say I want to find the specific volume at a certain point. It's going to be equal to, well, the specific volume at F plus quality times V sub Fg. I can figure out the entropy at any point along there. It's equal to and when returning back to this photo, you'll see just the shape of a line. We see that the temperature went up, then temperature remained constant. I was just getting a phase change, and then I started getting superheated steam. And I see the equation for superheat was equal to the actual temperature. Actual temperature minus the saturation temperature would give me degrees of superheat. We go ahead and take these right down here, just put them right there on that line, and that's what would happen on the TS diagram. we're going to see these equations again.